This session is for OCR FP1. The topic is complex numbers and we're working through June 2010, question 10. So if we start by having a look at the question. So we're told that the complex number z has an argument between 0 and a half pi and is such that z squared is equal to 3 plus 4i. We're asked to find or to use an algebraic method to find z. And then in part 2 we're asked to show that z cubed is equal to 2 plus 11i. We're then given another complex number w, or omega, which is the root of the equation w to the power of 6 minus 4w cubed plus 125 equals 0, and the argument this time is between minus a half pi and 0, and we're asked to find w, or omega. So let's just have a look at the first part, where we're trying to find z, given that z squared is equal to 3 plus 4i. So the first thing that we need to do, really, is to let z equal a plus bi, where a and b are real. So that means that a plus bi, all squared, is going to be equal to 3 plus 4i. So we're finding the square root. So if we multiply out the left-hand side, we'll get a squared plus 2ab I minus b squared, because of course we get b squared I squared, but I squared is equal to negative 1. And that now we're saying is equal to 3 plus 4i. Now the only way that those two things can be equal is that their real parts are equal. In other words, a squared minus b squared is equal to 3, and their imaginary parts are equal, in which case 2ab must be equal to 4. So what we've got here really are two equations in a and b which we need to solve simultaneously, and we're going to do that by a method of substitution. So we could take this equation, divide it through by 2 and rearrange it to make a the subject. So that means that a is going to be 2 over b. And if we then substitute that into this equation, so that means a squared is going to be 4 over b squared minus b squared equals 3. We now have an equation in one unknown. If we were to multiply that equation throughout by b squared, then we'll get 4 minus b to the 4th equals 3b squared, which we could write as b to the 4th plus 3b squared minus 4 equals 0. And now we have a quadratic in b squared, which we should be able to factorise. So we could put a b squared in each bracket, a 4 in one, a 1 in the other, and it must be a plus 4 here and a minus 1 there, so we end up with our plus 3 squared. So we end up with two possibilities, either that b squared is equal to minus 4 or b squared is equal to 1. So remember what we said up here, a and b were real, so this is not going to give us a solution. This is the one that's going to give us a solution, and it tells us that b is equal to plus or minus 1. So now we know that b is equal to plus or minus 1. If b equals 1, then substituting back, we can work out that a is equal to 2. So that gives us a possibility of 2 plus I for our value of z. But if b is equal to minus 1, then a is equal to minus 2, and that would give us z equals minus 2 minus 1 I, and that of course is outside the range. Remember what the question said at the beginning. So this is not going to be a solution, because what we were told at the beginning of the question was that the argument of z had to be between 0 and pi over 2. So the answer that we're looking for is 2 plus I. So if we have a quick look at how the marks are awarded for that question, then you got a mark for equating your real and imaginary parts. So there was a method mark there, an accuracy mark for getting those two equations, which you then solve to find b equals plus or minus 1, so there was a method mark there. There was also a method mark, I should have said here, for getting the quadratic, so 4 marks at that stage, and then there was just an accuracy mark for getting the correct root, 2 plus I. So if we just move on to the second part, then the second part was asking us to find z cubed. So we know that z squared was equal to 3 plus 4i. We also know that z was equal to 2 plus I, which we just found. So z cubed, we can just multiply those together, and it's a show question, so I'll just do that carefully. So 6 plus 8i plus 3i minus 4, which is 2 plus 11i. So z cubed is equal to 2 plus 11i. So just 1 mark for that bit. And then we move on to the last part of the question, where we have this another complex number which we've got to find. And the important thing to look at this time is to see that this complex number is in what I would refer to as the fourth quadrant. So its argument is between negative pi over 2 and 0. So we have this equation, a quadratic in w cubed. It won't factorise if you look at it, so we're going to have to use the quadratic formula. So let's have a little look at that then. So we have w to the 6th minus 4w cubed plus 125 equals 0. So using the quadratic formula, we will be finding w cubed, which will be minus b minus negative 4, which is plus 4, plus or minus the square root of b squared, which is 16, minus 4ac will be minus 4 times 125, which is 500, over 2a, which will be 2. So we end up with 4 plus or minus the square root of minus 484 over 2. We shouldn't be surprised about the negative sign because we know it's complex, and the square root of 484 is 22, so it's minus 4 plus or minus 22i over 2. Sorry, that was a plus, so that's 2 plus or minus 11i. So we now have w cubed, but we want to find w, or omega. So we know from what we did earlier that the cube root of 2 plus 11i is equal to 2 plus I. So if you remember the results that we got from part 1 for z, and then we multiplied it by z squared to get 2 plus 11i. So we know that this is the cube root. So that means it must be the cube root of 2 minus 11i, which means that we're not using 3 plus 4i this time. Omega squared, w squared, must be the conjugate of that, which is 3 minus 4i. And if you sort of go back and do a similar sort of thing to what we did in part 1, then you'll see that the square roots, omega, will be either 2 minus I or omega will be minus 2 plus I. So that's sort of just working through part 1 again, but this time we have a minus sign here. It's the conjugate of what we were doing in part 1. Then of course this one is not going to be in the correct range, because remember we need omega to be between negative a half pi and 0. So that means that our omega is going to be 2 minus I. So 5 marks for that question. So if we just have a quick look again at how those have been awarded, then you got a method mark for attempting to solve this equation. Here you got an accuracy mark for ending up with 2 plus or minus 11i. You got a method mark for seeing here that in fact it had to be the cube root of 2 minus 11i. And a method mark for seeing that here that meant that you needed 3 minus 4i, the conjugate, and here an accuracy mark for getting the correct square root within the correct range. So 11 marks for the question in total. So it is, that last little bit is quite tricky. However, don't forget that if you want to look at more revision videos, then those can be obtained by going to the Further Maths website and following the link.